This is Algebra 2, Lesson 2.2, Solving Linear Systems with Graphs. Okay, so we talked about linear equations. That's just y equals mx plus b, or even like ax plus by equals c, right, are just one line. A linear system is when we are looking at two lines. There we go. When you have two equations, and when you do that, you're going to maybe graph, right? We're talking about graphs in this section. And you'd have a line here, and you'd have another line here, and we are looking at where those two would intersect. Your solution is going to have an x answer and a y answer, because it's going to be an ordered pair where they cross on the x-axis and where they cross on the y-axis. So I probably could have had this over here, because that's what one solution would look like. You'd have one line here, you'd have a second line here, and wherever they intersect, that is your solution. No solution would look like this. And we call those parallel lines. Parallel, that's an R. Let's make it a big R. Parallel lines, right? Because they're never, ever, ever going to cross. You will see this happen when your equations have the same slope, but different intercepts. Infinitely many solutions, and let's go colorful in this one. So you have one line here, and then your second line would actually be the exact same line. They are infinitely many solutions because they are always, always, always on the same. So that is just when you have the same line. And that could happen when you have a multiple, or like if you have one in point slope form and one in standard form, and then when you solve them, they come out to be the same exact equation. Okay? So let's do a couple of examples. Solve the system by graphing. First one, we have two equations in intercept form. So I already know the slope and or the y-intercept. Those are going to be the simplest way to graph. So the first one here, we have the slope is 3, right? Because it's the number in front of the x. And then we have the intercept is 0. If there's no plus anything at the back, there's always a plus 0, we just don't write it there. It's helpful to have a slope in a fraction, so instead of just writing 3, I write 3 over 1. Because you can always divide a number by 1 and it doesn't change it. So this is telling me I'm going to start at 0, and then I'm going to go up 3, and I'm going to go right 1. And I'm going to repeat that constant rate of change until I have enough points to form a line. So we start at 0, that is my intercept value. Then I'm going to rise 3, and I'm going to run 1. And there's my second point. I'm going to go off the graph, I'm going to eyeball one more, just so I can have a couple points. Rise 3, run 1. Now the thing about slope is you can go backwards too. So if I went up 3, right 1, I can also go down 3, left 1, right? So if I was here and I went down 3, left 1, down 3, left 1, down 3, left 1. And I would say you need enough points that you get a clear picture of where the line would go, and then you can freehand it or grab a ruler if you want it to look extra pretty. But there's my equation, y equals 3x. Okay? The next one I can barely see at the top of the screen, but I need my slope and I need my intercept. So the intercept I think is a little more obvious to me. We have the number with no x, that's a 2. So I know I'm going to start at 2. Now the slope is the number in front of x, and in this case I just have an x, there's no number in front. But remember, no number in front of an x is the invisible one. And no denominator is also an invisible one, so that means I'm going to rise 1, and I'm going to run 1. So from my intercept, up 1, over 1. up 1 over 1, up 1 over 1. And then we can continue that pattern backwards as well, down 1, left 1, and connect our points to get the line y equals x plus 2. Now I said the solution to a system of equations when graphing is always where the points intersect, and here we can see the intersection of the 2 points. Then we're going to give the coordinates of that point. So that point from the origin is over 1, up 3. So from the origin, we went over 1, so our x is 1, and then we went up 3, so our y is 3. Right? Our x-axis is always how far left and right. Our y-axis is always how far up and down. And that is it. I got one more example, starting off with some equations that are not in intercept form, just so we can kind of see how those will work. So, for the first one, x plus 3y equals 9, you do have the option of converting this to intercept form. We practiced that in the last lesson. You could minus x both sides, divide 3 both sides, or you can look at the intercept values. I don't know which method I want to do. I'm going to go with intercept values. I think you can do this if you want to, like 3y equals 9 minus x, divide by 3, y equals 3 minus 1/3 x. Ooh, that's not what I wanted. What happened? There we go. Minus 1/3 x. Or the x-intercept would be 9 over 1. That's off the graph, so I'm going to go with the top one. And then the y-intercept would be 9 over 3. I think we're going to go with the top one, just because my graph doesn't go all the way to 9. So we'd have a little bit of problems there. Okay, so, long tangent. I did minus x on both sides. And then I did divide by 3 on both sides. And here's my equation. So that means I'm going to start at 3. And then I'm going to minus 1 over 3. Minus 1 over 3. So that's down 1 over 3. Down 1 over 3. And you kind of see if I did go down 1 more, that would give me to that 9, but I'm way off the graph. I'm going to go backwards just to get one more point on there. So if I went down 1, right 3, I'm going to go up 1, left 3. And I could go up 1, left 3, again I'm off the graph, but we can draw in that line there, and that would represent x plus 3y equals 9. Mine's a little low, but the next one is in point slope form, which means we're going to start on the point 3, 2. This is always the opposite, because it's a minus 3, we have a positive 3. And then this is normal, 2 is 2. So I'm going to start at 3, 2. Uh-oh, I already found my answer. But from there, we're going to rise 4, run 3. And we go backwards. And I don't think I need to do one more. But if we connect those, we have our solution right here. And that is at the point 2, 3. Because from the origin, we go over 2, 3. From the origin, we go over 3 and up 2. Over 3, up 2. That's it. Good luck on the exercises. Please let me know if you have questions.